Welcome to Chapter 5, Section 1, Trig Identities. In this section, we're going to recognize and write the fundamental trig identities, and we're going to use those to simplify and rewrite trigonomic expressions. So I want you to recall your trig identity sheet here, and I'm going to highlight a few identities that we're going to use today in this lesson. So basically, the formulas and identities that we have over on the right side of our trig identity sheet, we are going to use all of these identities here and these co-function formulas. The sum and difference, the product to sum and sum to product formulas, we're going to get to those later. But pretty much all of what we have on the left, most of what we have on the left, and down in the bottom right-hand corner, that's what we're going to focus on. And we're going to use these identities to help simplify our expressions and functions. So have this sheet with you when you do your homework here. Let's look at an example here. Let's say we want to simplify sine of x times cosine squared of x minus sine of x. Well, we want to treat this just like any other algebraic expression and see what can we do to simplify. So let's first look at factoring. We can factor out a sine x from both of these terms. So let's do that. We'll get the product of sine x times cosine squared x minus 1. Now we have to ask ourselves, are there any identities that we can use to further simplify this? And if you look on your identity sheet, one of the identities you'll see is a trigonomic identity, the Pythagorean identity, that cosine squared x plus sine squared x equals 1. So that means that 1 minus cosine squared x is equal to sine squared of x. Well, we don't have that, but we're really close. This right here is just a negative of that. So if we factor out a negative 1, that changes our expression to a negative sine x times the quantity 1 minus cosine squared x. Well, why do we want to do that? Because this is equal to sine squared x, and if we're multiplying by another sine x, then we get a negative sine cubed x. And so this expression that we started with, sine x cosine squared x minus sine x, simplifies to a simple negative sine cubed x. Let's say we want to factor 4 tangent squared theta plus tangent theta minus 3. Well, this is the same as if we wanted to factor 4x squared plus x minus 3. And we know how to factor that. Go back to Algebra 1, use whatever method you want to do, whether you multiply the 4 and 3 together to get a factor paired that adds up to 1, or whatever method you want to do, but we can factor that. So this is going to be the same thing, but instead of x, we're just going to have tangent theta. So this factors into 4 tangent theta minus 3, and the other factor is tangent theta plus 1. Now, we could confirm this by distributing and finding that we end up with the same 4 tangent squared theta plus tangent theta minus 3. But this is our factored form. Let's try one more factoring before we get into the simplifying expressions. Say we have cosecant squared x minus cotangent x minus 3. Let's pull out our trig identity sheet and let's see, is there an identity that could help us here? One that could either eliminate the cosecant in terms of cotangent or eliminate the cotangent in terms of cosecant. So if we look on our identity sheet, we can find in the Pythagorean identities that we have a 1 plus cotangent squared theta is equal to cosecant squared theta. What that means is we can replace this cosecant squared x with a 1 plus cotangent squared x, and that minus cotangent x is still going to be there, and so is the minus 3. Well, now we can simplify a little bit to say this is cotangent squared x minus cotangent of x minus 2. Okay, so now it just comes to, let's factor it. This is the same thing as x squared minus x minus 2. So this is going to be cotangent x and cotangent x. And we have a negative 2 and a positive 1. And so that is the factored form. So before we could factor, we had to use one of our identities from our trig identity sheet, and then we can go forward with factoring the quadratic. So let's put those to use in simplifying this expression, sine x plus the product of cotangent x and cosine x. So before we do that, let's think about, well, what does cotangent x equal? Well, we know that cotangent is simply cosine of x over sine of x, and we're multiplying that by another cosine of x. And so if we do this, we notice we have a fraction in here, and to combine two fractions, we need a common denominator. So let's get a common denominator. Our common denominator will be sine x. And so to get the first term to have a denominator of sine x, we would make that a sine squared x plus cosine squared x all over sine x. Now, where did the sine squared come from? To get that denominator of sine x, we had to multiply by sine x over sine x. So that's where we get this sine squared. And the cosine squared comes from cosine times cosine. Now, let's look at our identity sheet again, and we see that, hey, sine squared x plus cosine squared x is equal to 1. So this is just 1 over sine x, which we know is cosecant of x. So this entire thing simplifies down to cosecant of x. Let's look at another one dealing with fractions and common denominators. Let's say we have sine theta over 1 plus cosine theta plus cosine theta over sine theta. Now, you might want to say, hey, this is just cotangent theta, which this is cotangent theta, but let's not jump to that simplification quite yet. Let's actually combine these two together, and let's get a common denominator. Well, since the denominators have nothing in common, there are no common factors, the common denominator will be the product of those two factors. So our denominator will be 1 plus cosine theta, that quantity, times sine theta. And so in order to get the first term to have that denominator, we have to multiply by sine theta on the top and the bottom, so we get sine squared theta. And in order to get the right term to have that denominator, we have to multiply by the quantity of 1 plus cosine. So this will give us cosine theta plus cosine squared theta. Now, once again, use our Pythagorean trig identities to see that sine squared theta plus cosine squared theta is simply equal to 1. So this is 1 plus cosine theta over 1 plus cosine theta times sine theta, and the 1 plus cosine thetas cancel out, and once again we get cosecant theta. So notice two distinctly different starting points, and yet they both simplify to cosecant theta. And you're going to see that a lot. All right, there's going to be a lot of different algebra tricks that we're going to do, and using these trig identities to simplify things down to the smallest, simplest form we can get. And a lot of times they might come up being the same, even though the starting points were very, very different. Another way we'll use these identities is to change the form of an expression. Say we have the expression 1 over 1 plus sine x, and we don't want it to be a fraction anymore. We want to rewrite this as a non-fractional expression. Okay? So in order to do that, we have to think about what is our denominator and how can we get that into a different form. And a lot of times, a technique that we'll use is multiplying by the conjugate. Now, you might ask, why are we multiplying by the conjugate? Well, you're going to see what happens here in a moment. And if you're also thinking, well, what is a conjugate? Think back to when we got rid of imaginary numbers in the denominator in Algebra 2, and when we got rid of radicals in the denominator, also in Algebra 2, we had to sometimes use this complex or irrational conjugate. And in this case, what is it going to be? Well, since we have a 1 plus sine x, it's simply 1 minus sine x. And if we multiply the bottom by that, we have to multiply the top by the same. And so when we multiply the top and bottom by 1 minus sine x over 1 minus sine x, we get 1 minus sine x, and in the bottom we end up getting 1 minus sine squared of x. Okay, distribute and the middle terms cancel, and that's what we get. And this is the reason, this is why we want to multiply by the conjugate, because we get 1 minus sine squared x. Well, what is 1 minus sine squared x? We know that that is cosine squared of x. Once again, looking at your trig identity sheet, this is another Pythagorean identity. And so this is 1 minus sine x over cosine squared of x. And you might think, we didn't simplify this at all. This didn't make it any nicer than what we started with. But this is a fraction. Think about what the fraction is and what it means. If we have a sum on the top and we're dividing that whole sum, we can divide those individual pieces. So this is the same thing as taking 1 over cosine squared of x and adding that with a negative sine over cosine squared of x. Okay, and now this allows us to simplify it into a non-fractional expression in that, well, 1 over cosine squared of x is secant squared of x, and sine over cosine squared, well, sine divided by cosine, if we look at this as sine x divided by cosine x times cosine of x, well, this right here we know is tangent of x, and then we're left with 1 over cosine of x, which is secant of x. So we have rewritten this 1 over 1 plus sine x into an expression that is the exact same, but it's not written as a fraction. And so these two expressions are equivalent. So before you come into class tomorrow, go ahead and practice a couple problems on page 379. Look at a couple of the odd problems, say in the first 25, 125. Look at the odd problems. You don't have to do all of them. Pick a few and just try them before you come into class. But the main thing is, make sure you have this trig identity sheet, and you need to know these identities. You need to be able to recognize these identities. Okay, these are the big three. These three boxes are the really big three identities that you need to have memorized. All right, now the other ones, the ones down here and these ones here, yeah, having your trig identity sheet to help you, that's fine. But you need to get these memorized so that you can quickly identify how to simplify these expressions. So tomorrow in class, you're going to continue practicing this, and you'll use your trig identity sheet and these examples to do some more problems.